Okay, Algebra 1, Section 2.3, Solving Linear Equations in One Variable. Basically, we're going to apply both of the previous lessons here. These are still linear because the degree is 1, so the highest exponent attached to a variable is an understood 1. The way we're going to do this is the first step is we're going to simplify both sides of the equation. We're going to apply the properties of algebra from Chapter 1 to do that. So if we can combine like terms, stuff like that. 2, we're going to isolate the variable, so we need to get the variable to one side of the equation, everything else to the other. We're going to do that using the addition property of equality. Then we're going to isolate the variable by itself using the multiplication property of equality. And then we're going to check it with the solution that we get. Basically what that means, so on number 2, we have 15 equals 2x plus 7. You'll see that both things apply here. We have a 2 attached to the x that's being multiplied, and we have a 7 being added to it. So the first section we did in Chapter 2 and 2.1, we learned how to handle that constant, the number without the variable that's being added. We discussed that we're going to do the opposite of what's being done. So if it was being added, I want to get it to the other side of the equation, so I'm going to subtract 7 from both sides. 7 minus 7 is 0. 15 minus 7 is 8, and that's going to be equal to the 2x that we started with. Now I'm going to use the multiplication and division property of equality. I'm going to divide because 2 times x, I want to get rid of the 2. Opposite of multiplication is division. I'm going to divide both sides by 2. 4 is equal to x. That's my solution. Now I'm just going to check it real quick. We said that 15 is equal to 2, and I'm going to replace x with 4, plus 7. 15 is equal to 8, plus 7. 15 is equal to 15. That's accurate, so our solution works. Number 12, I've got 6. It looks a little different. I've got 6x equals 4x minus 3, so I've got an x on both sides of the equation. The first thing I want to do is to get them both on one side. The 6 is understood to be positive. There's a plus in front of it. The 4x is understood to be positive as well. There's a plus in front of it that we just don't see. So I'm either going to have to subtract the 6x from the left side to move it to the right, or I can subtract the 4x from the right and move it to the left. I personally would rather avoid negatives. So I'm going to subtract 4x from both sides. That'll stop me. If I subtracted 6x from both sides, I'd get 0 equals negative 2x minus 3. So 6x minus 4x, if I have 6x's and I take 4 away, I now have 2x's equals negative 3. Now using that multiplication property of equality, I need to divide by 2. And I get x equals negative 3/2. When I go to check it, I'm going to replace every x with that. I had 6 times negative 3/2. When I replace that x equals 4 times negative 3/2 minus 3. 6 times negative 3/2, 6 times 3 is 18, divided by 2, that's going to be negative 9, equals 4 times negative 3 is negative 12, divided by 2, negative 6, minus 3, and I get negative 9 is equal to negative 9. That works, we're done. Number 30, again, I have x's on both sides. I could go either direction. I'm going to subtract whichever one's smaller. They're both positive, so I'm going to subtract the smaller one from both sides to keep them positive. So I'm going to subtract 2x from both sides, and then I'm going to move my constant to the other side. I have minus 5. I'm going to add that to both sides, lining it up with one it would be added to. So that cancels, that cancels. 5x minus 2x is 3x. 7 plus 5 is 12. Using that multiplication property of equality, divide both sides by 3. x is equal to 4. Now I'm going to double check it. 5 times 4, replace x with 4, minus 5 equals 7 plus 2 times 4. 5 times 4 is 20, minus 5 equals 7 plus 2 times 4 is 8. Took order of operations, tells me to take care of the multiplication first. 20 minus 5 is 15. 7 plus 8 is 15. That one is also true. Number 32, I've got 4x minus the quantity of 3 plus x equals negative 6 minus 3. So all my x's are already on the left side of the equation. When I really need to have, I need to have red flags going off right now. When I see that negative right there in front of a parentheses, I've got to have flags going off. I need to distribute that negative through. So there's an understood 1 there. So what I'm really doing is multiplying negative 1 times 3 and negative 1 times positive x. I know anytime I multiply by negative 1, all it's going to do is change my signs. So I know that this is going to become 4x minus 3 minus x when I distribute that negative 1 through. Equals negative 6 minus 3 is minus 9, negative 9. Now I'm going to combine my like terms over here. 4x minus x is 3x minus 3 equals negative 9. Remove my constant by doing the opposite. It was being subtracted, so I'm going to add. Okay, so when I add, I'm going to get 3x on this side equals negative 9 plus 3 is negative 6. Using the property, multiplication property of equality, I'm going to divide both sides by the 3. And I'm going to get x equals negative 2. When I go to check it, I'm going to do 4 times negative 2 minus 3 minus negative 2 equals negative 9, because negative 6 minus 3 is negative 9. 4 times negative 2 is negative 8 minus 3 minus a negative is the same thing as plus a positive equals negative 9. Negative 8 minus 3 is negative 11 plus 2 is negative 9 equals negative 9. So we're good. All right. So number 38, the directions tell us to identify each equation as conditional, contradiction, or identity. Okay, so what does that mean? Basically what that means is when we come to a solution, if it does work, like example number 32, we said x equals negative 2. We came to a single solution that did check. That's considered to be conditional. It's possible that when we went back and double checked it didn't work. That would make it a contradiction. And if both sides of the equation became identical to each other, that means any number would work, and that would make it an identity. Okay, so the way we're going to find this out is we're going to go ahead and solve this. We got x plus 3 minus 4x equals 2 times the quantity of x plus 1. Starting on the left side, I'm going to combine my like terms. X minus 4x is negative 3x plus 3 equals, I'm going to distribute. 2 times x is 2x. 2 times 1 is plus 2. I'm going to, on this one, I'm going to go the other way. I'm going to add 3x to both sides to get rid of that negative. If you'd prefer, you can subtract 2x. You just got to make sure you do the same thing to both sides. And because I moved that one to the right, I'm going to subtract 2 from both sides to get my constant on the left. Alright, so whenever I do these, I'm going to have 3 minus 2 is 1 is equal to 2x plus 3x is 5x. To isolate that variable, I need to divide both sides by 5. And I'm going to get x equals 1/5. Alright, so when I go to check it, I'm going to have 1 fifth plus 3 minus 4 times 1/5 is equal to 2 times the quantity of 1/5 plus 1. Alright. Order of operations says I need to take care of the parentheses first. So I'm going to have 1/5 plus, I know I'm going to have a common denominator, so I just kind of want you to see what I'm doing here. I know that that's going to be 3 over 1. And that would be, my 5 is my common denominator between all of them. So 3 over 1 is equal to 15 fifths when I multiply the top and bottom of 5, minus 4 times 1/5 is 4 fifths, equals, it's going to be 2 times 1/5 plus 5 fifths. 1 plus 5 is 16, minus 4 is 12 fifths. All I did was combine the numerators. Equals 1/5 plus 5 fifths is 6 fifths, times 2 is 12 fifths. So that one checks out, we're good. Let's look at number 40. So my answer there is not x equals 1/5. The question was identify whether it's a conditional, contradiction, or identity. So my answer is conditional because I had one solution and it checked out. Alright, so now I've got 4 times the quantity of 3x plus 2 equals 12x plus 8. When I go to solve this, I need to distribute this 4 through first. So 4 times 3x is 12x. 4 times positive 2 is plus 8 equals 12x plus 8. So we should see something there. We should see that 12x plus 8 and 12x plus 8 are identical. What that tells us is that no matter what I plug in for x, it will work. 12 times 0 plus 8 is 8. 12 times 0 plus 8 is 8. No matter what I plug in for x, it'll be exactly the same. That is an identity. So the trick there is if we can manipulate either one or both sides of the equation to be exactly the same on both sides, we know that it's an identity. Okay, number 43. Another red flag as soon as I look at this one. 3x minus the quantity of x plus 2. That minus in front of that parentheses needs to jump out every time. I know I've got to distribute it through. So that's going to become 3x minus x minus 2 when I multiply that times that and that equals 2x plus 2. I'm going to get my, let's see how I combine terms here. 3x minus x is 2x minus 2 equals 2x plus 2. So it should start standing out to us a little bit. 2x minus 2 equals 2x plus 2. Those are conjugates of each other. There's no way that there's any number I can plug in for x that would be true, because 2 times anything minus 2 is not going to equal 2 times that same number plus 2. But just to show you kind of what happens here, whenever I go to isolate it, when I subtract 2x from both sides and I add 2 to both sides, this side cancels out, that cancels out, so I get 0 equals 2x minus 2x cancels out, 2 plus 2 is 4. We know that 0 is not equal to 4, so that is a contradiction. Alright, that's all this section is about. We're just taking those last two lessons we learned, 1.1 and 2.1 and 2.2, kind of combining them together so that we can solve these bigger problems.